Yeah, good morning, everyone, for another minute. Thank you for coming. My name is Javier Carnero, applications engineer for Samtec, covering the UK and some parts of Europe. Today, we'd like to talk about connectivity. We get into the interesting part of the presentations of the day. And we look at the typical connectivity that we see around FPGAs and inside FPGA ecosystems. We'll split the presentation into two parts, one more for connectivity traditionally used on evaluation kits for testing and development, and then typical solutions that we see on the end products around FPGAs, especially for board-to-board. We could discuss more about high-speed signaling over cables, for example, optical transceivers, but for today we'll focus into board-to-board connectivity. So FPGA development kits, so basically they are tools for yourselves to start working on an FPGA, so you are able to get some I/O into different functionality through different connectors. There are multiple options that you can use. Some of them will be used for high-speed signaling, for example. Some others, they are interesting because they offer a high number of I/Os, so it doesn't need you to do high speed always, but maybe looking at the high I/O capacity of FPGAs. So when we look at these expansion modules that are on FPGAs, there are probably three standards that we see more often. P-modes. P-modes is based on pin headers and sockets, very versatile, especially for I2Cs, even CAN signals. But you will probably not like to get a high frequency signal like a JSD or an Ethernet signal over that kind of connector. You might be able to do up to certain frequencies. So we normally say about 1 gigabit is okay for that kind of pin headers and sockets. You can probably get more out of them, but it will cost you at the same time more into the design of the PCB. So probably it's not worth doing back drilling on low-cost FPGAs just for the sake of saving some money on the connector design. Then the next one is QB. There's a newer standard that expands on. It's not exactly like P-modes, but it offers a more versatile solution up to 5 gigabits, so you can get into a little bit of high speed. And the last one I want to talk is FMC, which is probably the king of FPGA connectors and evaluation kits. Most of FPGA evaluation kits will have one or two of these connectors in two flavors. It can be the original FMC, Beta 57.1, or the latest revision, Beta 57.4 FMC Plus, that expands on the number of pins. So if we look at the typical FPGA evaluation kits, so this is a good example from our friends from Arrow, where they did this evaluation kit for Intel. And in here you can see a lot of I/O, so you can go directly high speeds to optical transceivers from here. You can do video signals over USB, for example, if you wanted to. But the important thing is adding this add-on cards to get for the functionality. So if you want to connect your FPGA with an analog to digital converter, for example, to get some JSD signals into the FPGA to see the link is working. In that case, in most cases, is where you stand to use the FMC, an FMC Plus connector. So yeah, FMC, for the ones not familiar with the product itself, is just an add-on card that you get some normally I/O or different functionality. So on this one, for example, we did this one for Xilinx to get the high-speed signals from the dep kit directly to front panel optics up to 28 gigabits per second. So they wanted to respect the standard, only offering 10 gigabits on the connector, but they wanted to bring 28 gigabits performance into adjacent connector to the FPGA. So this is a different example, but this is the typical architecture that you see for development. You have an FPGA. You want to test, for example, an optical functionality. So you just get a standard pinout PCB. So it will have your power, it will have your high-speed signals already defined. So every time that you plug an FMC card, you know what you will have. So you will have a fully interpersonal device. At the same time, many people ask, okay, I like FMC, I like the high density that it offers. Can I have my own FMC cards for my end product? And the answer is yes. The connector that we use on FMC is a very rugged connector, the C-Ray connector. We can talk about it later on. But we see a big interest from customers on designing their own FMC cards on their own FPGA carrier cards. So obviously you will not use an evaluation kit on production, but at the same time you will design a similar carrier card that will offer the functionality that you are looking for. So when we look at the FMC, there was an evolution initially released in 2010 by Beta organization group. The Beta group looks at different standards, mostly for the military aerospace type applications. And the FPGA manufacturers, they said that they needed a standard so customers could evaluate different functionality. So we started with a 400-pin connector, the original FMC, which is available in two flavors. You have the high pin count and low pin count. It's based on exactly the same connector. The idea of Beta is you can plug an FMC low pin count card into a carrier card with a high pin count connector, and it still will work. So it's the same connector, but we only fill the number of contacts as required. Interesting here, the original FMC it was limited to 10 gigabits, but when you look at the 57.4 FMC Plus, gets up to 28 gigabits. And nothing changed in the connector. We only add more columns, so it moved from 10 rows into 14 rows. So the connector is exactly the same. So the connector is never changed. You can actually get even more out of this mated set. It was just the standard. When we released C-Ray, even before 2010, 10 gigabits was not really typical. Not many people, there were not many SerDes available at 10 gigabits. Now we see SerDes up to 112 and even 224 gigabits. So the connector is exactly the same, the standard changes, and now it's written up to 28 gigabits. So for many people, they ask me, okay, can I use an FMC mated set for 28 gigabits? The answer is yes. You can do it. Obviously, look at after the design into the PCB, but you can do it. And at the same time, it grew the number of gigabit transceivers. So it went up from 10 gigabit transceivers to 24 with an option for an expansion that you can add another 8 gigabit transceivers. So up to 32 gigabit transceivers that can be used for Ethernet, JSD, PCIe, any kind of signal that you want to use over the connector. So the standard itself, I don't know if many of you are familiar with the standard, if you have designed any of these cards, but from the Beta organization group, you are able to download the standard, and it will tell you the exact pinout that you need to use to offer compatibility with the standard, and also the mechanicals. So the standard itself defines a region for I/O. So for example, if you have a RF front end, with converters connected to SMA connectors into antennas, you will have a region already defined for this connector. So basically, when it plugs into the evaluation kit, it doesn't mess anything around. So yeah, FMC has been giving a lot of versatility to FPGAs at the time of doing some designs for engineers. So it's a great tool to use. So now, we look at the interesting part of FMC, which is the connector. The standard writes the Samtec C-Ray connector. It's a dual source, so there is a dual source available for this connector. But when we design this connector, it's what we call an open pin field array. So basically, you can define what you want to use the pins for. So they can be used either for high-speed signaling, differential pairs, single-ended, power, so you can connect together as many pins as you want to get a power rail over the connector. If we look at the 500-pin C-array connector, you can get up to half an amp per pin. So effectively, it's a 250 amp connector in a high density and low profile at the same time. So what we are doing recently, especially since the advent of RF socks, so we had some silicon partners coming to us and saying, okay, I have this RF sock that now offers the functionality of getting RF signals directly into the chipset. Can I use your connectors for that? So if we look at the S parameters that we did back in the day, so we can see that return loss and insertion loss, it's really good up to certain frequencies. It really depends on the stacking heights. When we mention here 56 gigabits performance, it doesn't mean that you can do 56 gigabits on every single stacking height from 7 millimeter to 18.5, because the S parameters will change quite a lot from one height to the other. So we started to work with them on different modeling, different simulations, improving the footprint design on the PCB, looking at different PCB materials. When we first rate C-Ray, we use FR4 material, so it's a high loss material. If we start to get into C-Ray, into lower loss materials like MT40 that we use quite often on some evaluation kits, we can see that the performance gets much better. So the reflections inside the connectors, we cannot change them. We can maybe change the capacitance around the connector, and it will change the performance of these parameters. But there's a certain level of things that you can do around the connector itself. So now we can get up to 8 gigahertz of RF signaling, differential pair, especially for RF SOC. But we also have many customers asking if you can do single-ended RF over that kind of connectors. And the answer is yes. So if you're looking, for example, on a connection where you have 10, 14 SMP connectors for a board-to-board connection, you can do that with an array product. And it will save you a lot of space on your board, and it will save you a lot of cost. Because traditional RF connectors, they are machine-based, so it takes a higher cost than building a stamp and form contact into a molded plastic, basically. So it's just the manufacturing cost of the different device. So in here we use our edge rate contact. So when you see the Samtec catalog, you see lots of different board-to-board connectors, and sometimes you are not sure which one is better for my application. Some people, they are looking after high vibration environments. Some others, they're looking after high speed. So with our edge rate contact, we kind of have the sweet spot for almost every application. So it's a really rugged connection with high mating surface. Into it is made of beryllium copper, so it can withstand vibration really well. We can actually pass environmental requirements similar to military type standard, MIL 810, for example, and is nowadays even used into space applications. We use LCP resins that they are load gassing. We do our own plating in-house, so we can do easily thin lead plating, which is becoming more rare into the industry, finding a standard thin lead plating, so we can do it as a standard, no MOQ, so we try to make it easy as Samtec, to be honest. We work a lot with Vita and FPGA manufacturers, so sometimes they ask us for different features. So we have some tools that are helpful for designers. So if you have a very expensive FPGA kit, 10 grand maybe, and then an FMC card that is 2 grand, you don't want to really jeopardize it because you don't make a proper mate into the connector, because they are high retention. There's a lot of pins in there, high retention. So we started to work on FMC extenders, for example, so you can have your FMC cable directly into the card and then just plug the cable into the mezzanine card. We did that kind of cable thinking about signal integrity, so you are able to get the full functionality of the FMC up to 10 and 28 gigabits. Then we do this connector saver. Again, many people use it for extender, but in reality, you can use it just for a connector saver and protect your really expensive piece of kits for development. So this is about development ecosystems. So obviously, once you move from the development stage, you need to build a product. In many cases, we see that customers like to use system of modules. So a system on module is basically an FPGA card. It can be a processor. There are different types of SOMs. And you can buy them off the shelf. So basically, if you are thinking on using an FPGA for a certain functionality, but you don't have the resources of doing the FPGA programming, you can speak with some manufacturer, and they will be able to write all the code that is required for your application, and you can buy an off-the-shelf module. And in this case, in most of system on module that you will see in the market, there is normally a Samtec connector attached. So one of the biggest questions on system on module is standardization. So many people will have their own footprint with their own connectors, their own sizes to fit the applications where they start the design on. But there is a push in the industry to try to standardize it. So people try to use other standards, even PC 104. We see some system on module devices that they are based on PC 104. XMC is another typical for FPGAs, and probably the group that is trying to make it more global and completely fit for purpose is the SJET group. So they are working on what they call the harmonized FPGA module, and this will be coming in two flavors. One that will be directly soldered into the PCB. It will be a PCB with solder balls that you solder into a carrier card, where you design your own I/O. And the other one is a connectorized harmonized module. On the connectorized side, there's still the working group in process, so we cannot really disclose anything unless you are members of SJET. But obviously, at the same time, we are pushing for some connectors because we have all the legacy of being used by multiple manufacturers. So probably the most common one that we see at the moment is the Crea module from Xilinx that offers a lot of versatility with the MP-SOC devices, so you can do a lot of different things, not just high speed. Why using that kind of connector for a SOM? So normally what you want is high density. So in here you can see you have for the Crea, you have 480 pins across two connectors where you can get up to 56 gigabits. So if they want to evolve the Crea at some point and start to get some 56 gigabit SerDes, they will be able to use the same kind of footprint architecture and just changing the carrier card. So you may need high density, high speeds, as I said, power. So if you need to mix up power and signal into the same connector. Again, we try to make it easy to tell you how many pins you need to allocate the power rails that you need in that case. And also mechanicals. So the way that we manufacture our array products is we are flexible. So we build the bodies and the pins, and we are able to have different stacking heights. So you can go all the way on the specific series from 5 millimeters stacking height to 18 millimeters. So depending on your mechanicals, you will be able to to fit a solution or a different one. So you can go up to 400 pins, or you can go down to 40 pins. So basically the 40 pins is the size of probably a 20 pin or a 10 pin 2.54 pin header. So if you want to miniaturize your devices, you will need to start to move into smaller pits. So this is a little bit about the evolution on the array products. So we started with C-Ray 15 years ago. Great products, a lot of versatility. It's still the most flexible solution that we can do. Is vertical connection. You can also do right angle to vertical, like a micro backplane. You can even do coplanar connection. So C-Ray is actually quite popular within beta. XMC has been evolving, for example. And now, recently, it was released the XMC Plus that is also using C-Ray. What we did in there, we changed a little bit on the footprint to make sure that they are footprint compatible. And now Beta is also ratifying C-Ray as the connector for the Beta 90 for micro backplane used into rugged type of applications. And from there, we started to develop based on customer feedback. So they said, okay, we need a higher density connector, C-Ray is 127, so we moved into a 0.8 solutions, almost half the size from the original C-Ray, to suit different applications. Then we have customers saying 7 millimeters is too high for us, and it's something smaller. We developed the low profile array, which is 4 millimeter stacking height. And again, this is also used on FPGA ecosystem for RF SOCs. It's what Xilinx will call the RFMC connector. Is based on the low profile array. And we try to give a whole new branding to the array products, and this is where we started to work with the Accelerate product, 0.635 millimeter pitch, multi-row, and here it comes in 3 flavors. Here we have 2, the high density, which is the Korea connector, and the high performance. The difference between them is similar stacking heights, similar performance, but with the HP connector you can get up to 112 gigabits, and it's basically down to the distances between the columns. So Accelerate is focused extremely on high density, high performance. We're looking at the balance between high density and performance. So what we do is we space out the columns, the rows, into 2.2 millimeters, so it reduces a lot the crosstalk between the columns, and it allows us to get into higher speed performances. And a completely different beast is the Nova Ray. Nova Ray is not an open pin field. Nova Ray is a full differential pair. So the way that we manufacture it is 2 pins fully surrounded with a ground plane already. So this one is 100% focused into the extremely high speeds or high frequency RF signals on the differential side. So you can probably get more than 10 gigahertz of RF signaling over that kind of wall-to-wall connectors as well, which is quite impressive. So there is not a better connector, it's just a better connector suited for your application. So that's why many people say, oh, I started the design with Nova Ray, but maybe the price position is not what I was looking for. And when we look at the application, we are like, okay, maybe you can get away with a C-Ray or with an Accelerate. So that's why we always said, come to us, because there is a lot of support that we can offer beyond that, what you see on the web page. On the web page, obviously, you will have 3D models to download, so you can 3D model your products. You will have S parameters, measurements, so you can see the performance at a certain frequency that you're working on. But if you want these S parameters, we can also provide them to you. If you are doing a full channel modeling from chip to chip, and you want to decide to model, for example, in ANSYS, we can provide you with HFSS models of mated set of connectors. So all of this information is also available. We like to say, come to us, because we like to support you on your design. We are very proud that we have a big signal integrity team that is supporting with people all over the world. So there's a lot we can do for you. We can provide you with footprint recommendations as well. So if you are starting a new design that you need to get 28 gigabits over a connector, we can understand what is your PCB material selected, and we can maybe provide some recommendations on the footprint design. So it also saves you a lot of time designing it by yourself. So the other typical connections that we see on some module, this is more into the high density type application, not specifically looking at high speed. Some of these connectors, they can get certain high speeds. So like, for example, this LHM, you can get easily to 10 gigabits. Again, depending on the PCB materials that you're using, depending on the whole channel that you have, the length of the trace over the PCB. So there is a lot of variables to make a connector rated. So when we rate connectors, we normally look at the S parameters, return loss, insertion loss, and we assign a data rates. But obviously, it's not in the whole channel. So if you want to see how the connector is looking in the whole channel, is where we can discuss about it, where we can provide you the S parameters so you can simulate your whole channel and see the actual performance of your device, not just the connector itself. And again, a few series that are quite popular. I think I'm overrunning time. Oh, no, sorry, I got 5 minutes more. So in here we see mezzanine type connectors. Again, the message here is you have multiple options that will fit different applications and different requirements. So if you want something that is really robust, maybe we can recommend you other connectors that if you're looking for really good signal integrity. Normally, again, edge rate series, where we use the edge rate contact, is the sweet spot for most of applications in 0.8, 0.635, and 0.5 millimeter pitch, different stacking heights. We can even bring shielding into the connector, so if you are in a very noisy environment, that will be helpful for you. And again, similar flexibility in terms of stacking height and configuration, micro backplane, right angle to vertical, and coplanar connections. This one is a really good connector. It actually performs better into a coplanar connector than the C-ray connector. Obviously, the C-ray, as you get that many columns, the right angle creates a construction of the pin, creates a lot of reflections within the connector, so it's not as good for high speed as this one that is very small. The reflections are really low on this connector, so you can get easily to 25 gigabit into a coplanar connection with this system. And then again, if you need like a flexi-rigid connection, that type of extremely low profile, down to 2 millimeters. We also have interposers that they are 1 millimeter. They're actually one of the best performing, just because of the height of the body creates less reflections than any stacking height, any higher stack that you may use. So yeah, a lot of different options, but the message here is to get away is all the support that we can offer you during the design stages. So it's what I mentioned before, all about these parameters. Where are you working? I'm working at 10 gigabits. Okay, this connector will provide you with certain return loss. Maybe you will be looking at another one. You want to do your own characterization of the mated set that you're using. We also have evaluation kits available, so you can hook them to your VNA, and you can see the actual performance, and you can get the model into your system. We also do seminars. We got the Geek Speak seminars. Here, we don't speak that much about connector solution. It's about challenges. So, for example, interesting ones is about getting PCI Gen 4 signals over a long reach over cables against PCB. So how far you can go over a cable compared to a PCB. So sometimes if you're looking for something that is, you need a certain encoding on your signals, but you need to use the you don't need to use the mechanical features of this standard, like PCI, for example. So we look at these kind of things. We also look at how to test high-performance systems, how to test 112 gigabit SerDes silicon, for example. There is a lot of information that we provide in these seminars. And yeah, then the web page, we are very proud of our web page. We hope it's really easy to use for all of you that use this web page. You have 3D models available. You can configure your part number, download the 3D model, asking for free samples. But again, if you want to have a better feeling for a connector, a 3D model doesn't tell you a lot about the robustness of a connector. So if you want to have a look at the connector and you don't want to solder a PCB with your samples, let us know, because we can send you demo boards and you can destroy them and play with them, do whatever you want with them. Test reports, so you can see the power you can draw from through the connectors. You can see these parameters, and you can see shock and vibration that this connector are designed. Well, these connectors are tested. We never test to fail. We always test to a point that we know it will perform at a good point. So many people ask, what is the mating cycles on this connector? And we say 3,000. But when we test to 3,000 mating cycles, it's to a point that we know we are not damaging the plating on the connector. We don't see any kind of increased contact resistance. So in reality, we have many people that they do their own test for their own application. And we can also support with that. We have a test lab. So if you tell us, okay, I got this shock and vibration profile, I want to know if your connector fits into it and if it will work. So we can take it to the lab, and we can do the testing for you on environmentals as well. And then some really easy to use tools. So basically, you can select with the solutionator. We have solutionators for different ranges, so you can build your RF cable, selecting interfaces, diameter of the cable, and you get a part number. You can get free samples, or you can get pricing from the web page as well. And the same thing for the board-to-board. So you select the number of pins, the pitch that you want, and the orientation, and it will provide you with a mated set where you can download the 3D model, see the test report, and again, asking for samples if you need it to. And this is all I have for today. So I don't know if you have any questions. Anyone has got any questions? But if you have any questions later on, we are right at the beginning as you come out the stairs. Difficult to miss is a big orange booth. We are there. So, yeah, thank you, everyone.